In today's math lesson, we will learn about prime factorization. This is for September 30th and October 1st. Now I want you to think. You should have learned what a prime number is. Think to yourself, what is a prime number? We're going to look at this number table and we're going to think. All right, now we're going to take a look at this number table, and we are going to cross out all the numbers that are not prime numbers. So numbers that have more than one factor pair or more than two factors. So the first number that we're going to cross off, well, to back up, 1 is not considered a prime number since it only has one factor, which is 1. So that's not considered a prime number. You can argue and argue, but it's not considered a prime number. 2 is a prime number, and we should leave this on the list because there's only 1 and 2 for the factors that go into 2. But since 2 is going to be a factor of 4, we're going to cross out all of the even numbers. So 4, 6, 8, 10, 12, because we know 2 goes into there. They might have other factors, but we know that 2 goes in there along with 1 in itself. I'm going to speed things up. Do you kind of notice how everything in this column gets crossed out? Everything in this column, this column, this column, and this column. All right, now we're going to go on to 3. 3 is a prime number because it only has 1 and 3 as the factors. But any multiples of 3 are not going to work. So 3, 6 is already crossed out. 9, 12 is already crossed out. 15, 18, 21, 24. Do you notice that every other one is not crossed out yet? 24, 27, 30, 33, 36 is already, 39, 42 is already crossed out, 45, and, sorry, back up. I was going too fast. And 48, but that's already crossed out. So those are all the multiples of 3. Now, why do we not cross out all the numbers that have 4 as a factor? 4, 8, 12, 16. What do you notice about all of those numbers? Yes, they're all even and they've already been crossed out. Now 5 is also a prime number, so let's put those in yellow. So, oops, that's not considered. 2 is considered prime, 3 is considered prime, 5 is considered prime. But now we need to cross out all the digits that, or all the numbers that are multiples of 5. Well, if we think about it, all the ones that end in 0 are already crossed out. So now we just need to cross out 25, 35, there we go. Okay, now we're on to the 6s. We don't have to cross out the 6 because it was a multiple of 2 and a multiple of 3. How about 7? Yes, 7 is a prime number. So now all the multiples of 7 we need to cross out if they're not already. 7, 14 is already crossed out, 21, 28, 35, wow, they're already crossed out. 42, 49 we get to cross out. Now let's go on to 8 and 9, they're already crossed out. And the rest of these numbers are prime numbers. So let's go and highlight them. 11, 13, 17, 19, 23. I hope I didn't mess up. I might have. Nope, not so far. There we go. Those are all the prime numbers, 1 to 50. You are just going to need to memorize these prime numbers. That's going to be your, oops, not that one. That's going to be your best bet, is to memorize the prime numbers, so you automatically know. Now I'm going to teach you something that I just learned. There is something called twin primes. Twin primes. So there are some pairs of prime numbers whose difference or subtracting is 2. These are called twin primes. Notice, so all the yellow ones, 3 and 5. If I subtract 5 minus 3 equals 2. Those are twin primes. We also have 7 minus 5 equals 2, so that's a twin prime. I want you to list all of the twin primes on this chart. Put it in your tasks. This is page 19. Put all of the twin primes. All right, if you found the twin primes, you would have found 3 and 5, 5 and 7, 11 and 13, 17 and 19, 29 and 31, 41 and 43. Remember, when you find the difference, you are subtracting. So 5 minus 3 is 2, 7 minus 5 is 2, and so on. If you said a prime number is a number that is greater than 1 and it has only and exactly 2 factors, 1 and itself, then you are correct. So 5 is a prime number because it is greater than 1 and its only 2 factors are 1 and itself. So now I want you to go to textbook page 19. Actually, I'm going to be taking. Now we're going to look at the factors of 12. So what numbers go into 12 evenly? We know that 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And we know that the 6 and the 12. Now I want you to look at all these factors and list the prime numbers. Which ones are prime? You should say 2 and 3. Those are the prime factors of 12. So we just found all of the prime factors of 12. So now we are going to add the prime factors in this. 12 equals, we had 2 times 3. That would equal 6. And we're missing one more digit. What other prime number between 2 and 3 would we multiply 6 to get 12? Yes, 2. Because 2 times 6 is 12. 12 equals 12. Now what we're going to do is we're going to find prime factorization of a number. One method is to use a factor tree. This is supposed to look somewhat like a tree. So if I start with a number like 72, you want to think of the multiples of 72. So I know 8 times 9 is 72. But I know 8 can be broken down into other factors that are, because 8 is not a prime factor. So then we would do 4 times 2. 2 is a prime factor, so we stop there. 4 we can bring down to 2 times 2. And we already have the 2 here. So now what times what equals 9? 3 times 3. And we know that 3's are prime. So if we go 2 times 2 times 2 times 3 times 3, that is the prime factorization of 72. You might have thought 12 times 6 equals 72, which would have been just fine. Your tree is just going to look a little different. We know that 12 is not a prime number, so we need to factor those out. 3 times 4, 3. That's done. It's a prime number. But 4 can be brought down to 2 times 2. 6 is not a prime number, but if we multiply 2 times 3, then we have the prime numbers, and those just go right here. So the way to show prime factorization is 2 times 2 times 3 times 2 times 3. The second way to find prime factorization is to continuously use division, starting with the lowest prime number as a factor. So 2 goes into 72. Now we're down to 36. What goes into 36? Well, we know that it's an even number, so 2 goes in there again. How many times? 18. Now, what times what equals? Another way to find prime factorization is to use continuous division, starting with the lowest prime number that is a factor. And we know that this is an even number, so 2 goes into that. 2 goes into 72 36 times. We see again that it's an even number, so divide by 2. 2 divided by 36 is 18. Another time, it's another even number, so 2 divided by 18 is 9. Now, we finally don't have an even number, but what's the next prime number that goes into 9? So 3 divided by 9 is 3. And 3 divided by 3 is 1. So we do not consider that a prime number. So now, over on this side are all the numbers that we need to use to prime factorization. So 72, and there's 1, 2, 3 2s. So 1, 2, 3 2s, and 2 3s. That is the same as the factored trees. Now, when we write using exponents with this big number, 72, first of all, we have to group the same numbers. So we have 3 2s and 2 3s. So in other words, 72 is going to equal 2 to the what power? How many are there? 1, 2, 3. 2 to the third power times 3, and how many 3's do we have? 2. So we could write it like this. 72 equals 2 to the third power times 3 to the second power. Now I want you to look at this example. 2 to the fourth is read as 2 to the fourth power. I want you to think of the value. We know that there's going to be 4 2's. 1, 2, 3, 4. What is that going to equal? Well, if we do 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth power is 16. I want you to find the value of 4 to the third power. And write this in your tasks. So when you did this in your notebook, you should have gotten 4 times 4 times 4. Because 4 to the third exponent, there's going to be 3 4s. Well, I know that 4 times 4 is 16. And multiply by another 4. Oops, 2, it's going to be 64. Let me erase this. I made a little mistake. So 4 to the third power equals 64. Now in your tasks, or in your notebook, in the tasks section, I want you to complete 4, 7, 8, and 9. I will show the answers in the next slide, so pause this video. And here are the answers to the tasks. 4A, 3 times 5. B, 2 times 5 times 5. C, 2 times 2 times 3 times 3. And you can read the next one. If you got this one, good job. D, anything to the, if the base is 1, it's always going to be 1. Notice in 8A, B, and C, you always put the lowest base number first. So 2 to the third power times 5 to the third. 3 to the second, 5 to the second, and 7. And then 9 is 60, 24, and 100. Your homework is to work on exercise 5. Good luck. Now there is another way to show prime factorization instead of that long list of numbers. What we're going to use is exponents. If I put this number down, 3 to the 5th power, the 3, the bigger number, the larger written number, is the base. And this little number up here is the exponent. How you would say this would be 3 to the 5th power. 3 to the 5th power. What it means is 3 times 3 5 times. So 3 times 3 times 3 times 3 times 3. The exponent is 5, so I should have 5 3s there. 1, 2, 3, 4, 5.